Good afternoon. So thank you for connecting. We will start the next talk, and you can find the notes on the introduction to data science. And today we will be looking at data visualization libraries in Python. So that is our talk today. And this will be the part one, because there's so many libraries in Python that you can use for doing visualization that we will focus on only the two main ones. The first one is Matplotlib, and that's the traditional visualization library designed for Python. And then another library, Seaborn, which is constructed on top of Matplotlib. So you can consider that Seaborn is just a set of macros that use Matplotlib underneath to create visualization plots and also make your task of visualization a little bit more easy. And that's what we're going to be doing today. Okay, so I'll put the link in the chat. All right. So let's start. When you're working in Python, you have several options for doing data visualization. We have several libraries besides the ones that we're going to see today, Matplotlib and Seaborn. So it will depend what is the purpose of your plots and also what type of visualizations you're trying to do. The only difference between the different libraries is going to be the basic commands that each library have. And also if at the end you want to have just your data visualized, but also it will you will have the options of having an interactive plot or just in like a dead plot. Like when you print something, you cannot change or modify or anything. So that's the basic difference. So Matplotlib is the basic library, and the next one is Seaborn. And then if you are coming from the R world where you're using ggplot2, then plot9 has the same syntax as ggplot2, so you don't have to change your scripts. You just bring your scripts from R into plot9 and it will work. It will work. And also, you can always decouple the data analysis part from the visualization, because you can use whatever tools to analyze, clean, and explore your data. And then once you decide that your data is clean, then comes the visualization part. And that visualization part, you can do it in R using ggplot2, or you can use it, do it in Python using plot9, equivalent to ggplot2, or just use Matplotlib or Seaborn. And then if you want to have interactive plots, then probably you can use Plotly, or you can use Bokeh, which is another library. Bokeh is open source, Plotly is commercial, but you can use some free version, except that at the end you may not post your interactive plots on a public web server if you don't have a subscription to Plotly. And then we have other types, Altair, and then HoloViews, and ggplot, which was going to be something similar to the ggplot2. Okay, so let's start. So Matplotlib has all these different tools to create plots or visualization, data visualization, and you have all different options for colors. So you have to get familiar with color tables, for example. Let me open this. And then you have all the different color options. You have the basic colors, the red, green, and blue, and cyan, magenta, and yellow, and black and white. Or you can use different combinations. So here we have olive, we have pink, we have brown, purple. Then you have all these different color tables that you can use for achieving the desired colors you want to use in your plots. So you have many options besides the one that are standard in Matplotlib. And also you can combine different color maps from Matplotlib in Seaborn, etc. Okay, and then there's some tools online where you can play with your colors and get the specific codes for a specific color you want. So we have the color brewer and the Peloton. So let me just open them. So you are not tied with specific colors that come basic. So you can always play and just get the colors you want. SciPy is a library that is just a set of mathematical algorithms to solve, for example, ordinary differential equations or partial differential equations or do numerical integrations. So scientific Python or SciPy is just a set of libraries that do that. The colors, we will see that besides Matplotlib and Seaborn, we have already talked about pandas. So pandas also has some basic visualization functions we can use, but SciPy is different. So maybe you have seen plots done in pandas. So we will cover that today. And next week we will cover Seaborn with more detail. Okay, let me go back. All right. Okay, so pandas, we know that pandas is just a basic Python library for doing data analysis. And pandas includes some basic functions to make plots. So you can plot a line, you can plot scatter, you can plot histogram, you can plot a kernel density estimate, you can plot using hexagonal bins. For doing distribution plots, you have all these options. Relationship plots, it's just line or scatter. Then you can use these for categorical variables, meaning like string variables like gender or species. You can use box plots, boxes, and then bar plots. And then if you want to do scatter matrix, just one variable versus another one, you can use this function, scatter matrix, from pandas plotting. Okay, so I'm just going to talk about the different types of plots you can do in pandas, and then you can do the same thing in Matplotlib. So pandas is just for exploration of data and just basic visualization, very raw. But if you want to have something more professional, then you will have to use Matplotlib. Okay, so let's start with the anatomy of a figure. So these are all the terminologies you will read when you're looking at the different documentation from Matplotlib, which is very extensive. So we will see, for example, title. It will refer to this text that's up on the top of the figure. And we will talk about legends. When we have multiple plots, we want to distinguish between the different plots. So we have a line plot here in blue and a line plot in red. So the legend will tell us the notation or the labeling how we are going to distinguish one plot from another one. So this is a line plot. And then we have scatter plots, which is just a set of markers. And then you can play with different markers, not only circles, triangles, squares, and asterisks, etc. And also on the lines, you can have solid lines, so you can have different combinations of dashes, etc., dashes and points. Then we have the axis. So we have the x-axis and y-axis, and every axis can have its own label. And then on each axis, you can play with the ticks. The ticks is just the marks, the major ticks, like major tick here is 3, 2, and 1. And then you can have minor tick labels, like here you can break into smaller parts. And then these are the spines. The spines are just the bounding box that encircles your plot. You can eliminate the spines depending on what you want to do. And then you can create and enumerate different figures and put different captions. Okay, so that's the that's going to be our terminology, like X and Y labels, figure number, the major tick labels, the minor tick labels, and where they are and what symbols we're going to be using. Okay, see, those are the useful resources for Matplotlib. So you can always explore examples, and as any other library in Python, you will find when you select any figure you want, you will find an example how to create this specific plot, and you will find the code for doing that. And you can see that in this case, for example, it's a bar plot, and we have 4 types of fruits. We have the legend, we have the x-axis labels. So these are categorical variables. So the labels are apple, blueberry, cherry, and orange. And then fruit supply, which is some amount. It's just on the y-axis. And Matplotlib sometimes uses this pyplots library from Matplotlib, and we use it frequently to label our axis and maybe construct our plot. So in this case, we are going to use the subplots from the pyplot Matplotlib library. And in Python, you can define 2 variables, fig and ax. Fig is just going to be the figure, and ax is going to be used for the axis. And we have this is the initial data, just to list for fruits. We have 4 species of fruits, 4 types of fruits, the counts for each fruits. And then we can use this for labels, this list for labels, and these colors for this list of colors for colors. And then we're going to create a bar plot of the fruits and the counts using the label bar labels and the color bar colors, and then set the Y label fruit supply and the title fruit supply by kind and color, and the legend fruit color, and PLT show, and then you will create this one. So these are just, you can just copy, paste, and then adapt it to whatever you're trying to do. So they're very very easy to use. Then, okay, some basics, tutorials, and documentation is very complete. But sometimes what you do is post a question when you're trying to create a plot using, or visualization plot using Matplotlib. Just shoot a question in Google, like how to create a box plot in Matplotlib for categorical variables, and you will find many answers on the internet, specifically on Stack Overflow, where you will find different answers and different options to do it. or how if your labels are interfering between them, then you could probably rotate or change the size of the labels, the text labels, etc. Okay, so Matplotlib, you can import all Matplotlib and call it MPL. You can import the pyplot sublibrary from Matplotlib and call it PLT. And NumPy is just all the numerical mathematics, all the arithmetics and trigonometric functions are included in NumPy because you have to compute positions and where to put the labels, etc. So these are the basic functions again from Matplotlib. For doing relational plots, we have the scatter plot, the plots, horizontal line, vertical lines. For example, when you have a distribution, you want to say where is the average, then you can use a vertical line, or if you want to put boundaries, horizontal lines, a distribution plots, histograms, categorical plots, we have box plot, bar plots, violin plots, and also if you want to have multiple plots, then you can have these multi-plot grids, and we will see an example soon. Okay, so let's all these links to the documentation so you can read more about each function, and also at the end of each function you will find some examples. And so and in each example you will find the code that produces the example. Okay, and then once you find what you're looking for, then you just adapt it to what you want. All right, let's go back. And one more back. Okay. Okay, so plot 9, I briefly talk about if you are an R user, you just bring your code from R and it will work using plot 9. And these are the functions to create relational plots, distribution plots, categorical plots, matrix plots, and multi-plot grids. Okay, so let me open my Jupyter notebook. I'll post the link on the chat. So for visualization. Okay, and then you can easily open this Jupyter notebook with your Gmail account on Google Colab, and we do that. Okay, and going to close this, close that, close that. Okay, so now we have some examples. So I'm going to start with the basics of Matplotlib. All right. So we need to import several Python libraries to work. So we import the basic one, pandas. We have to read some data set or maybe clean it. Then we import NumPy to make some basic mathematical operations like square roots, or use the log functions or trigonometric functions or square, etc. And then these are the visualization libraries, Matplotlib. And I'm going to import Seaborn. We will go into the detail next week, and we are going to import Plotly for interactive plots and Plot9 for people who are used to plot in R. Okay, so in Matplotlib you can do two types of plotting. One will be the object-oriented plotting, and the other one is just the standard one. In any case, there's always more than one way of doing things. So if you're doing the object-oriented plotting, we will be using this AX variable. So let's start. X is just going to be a linear space. So like an array from 0 to 5, we're going to have 100 points between 0 and 5. If you are having difficulties, I'll just increase the font. So we have X, 100 points between 0 and 5. And then we will define two variables, fig and AX. And we're going to use pyplot, subplots, and we're going to define a figure size of 10 units in the horizontal and 6 units in the vertical. We're going to add a grid to visualize our plot. And then in this case, I'm not going to use external data, but I'm going to generate my data using mathematical functions. So from NumPy, I'm going to use the sine function, trigonometric sine function of X. And also I'm going to be plotting the sine function, sine of X, a linear function X, so Y equals X, and then X cubed, so cubic of X. And also I'm going to plot the sum of X minus X cubed over 6. And in this case, the first three are going to be plotted using lines, using the colors from default. But the last plot, I'm going to use a line style called dashed. And I'm going to label that one as the mathematical sum of the two terms. Then also I'm going to have control on the Y and X limits. So for the X limits, I want my domain going from 0 to pi over 2. So pi is just a number from NumPy. And on the Y limit, Y-axis, I'm going to plot from 0 to 1.5. Since we are involving a sine of X, and sine of X goes from -1 to 1 in the values, I'm just going to be plotting from 0 to 1.5 because my domain in X is just from 0 to pi over 2. Then I'm going to define where I want the X sticks. So the X sticks, I want them on 0, 0.125, that's like pi over 8. 0.25 pi, it's like pi over 4. 0.375 pi, that's 3 pi over 8. No, 3 pi over 4, and then pi over 2. So I want those X sticks, and in those X sticks, I want the following labels: 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. Then I'm going to set the labels for the X-axis. I'm just going to call it X. By the way, if you are familiar with LaTeX, Matplotlib understands LaTeX notation. So these are the mathematical environment for writing 0, pi over 8, pi over 4, pi over 8, pi over 2, the same thing as I'm using here the LaTeX to denote X cubed. And then the same label for Y-axis. Y is just going to be f of X. So between dollar signs, it's just the LaTeX notation for an equation. And the title is just a simple text. And then I'm going to add the legend. So if I execute this, yes, run. So I wait for the green check mark. And I have an error because I didn't load the libraries. So I have to load the libraries. Everything is standard. I don't have to install anything additional. Everything is installed in Google Colab. Then I just run it. And then I have this plot, right? So this is the first plot. I'm plotting 4 equations. I'm plotting in blue is just the sine of X from 0 to pi over 2. So has a value of 1. And then the linear X is just in orange. the cubic of x is in green, and the sum of x minus x cubed over 6 is going to be in the dashed line. So this is basically, if you remember from your calculus 101, that's the first two terms from a Taylor series of the sine of x. So the first two terms of the Taylor series approximate sine of x very well around x equals 0. And then as you go farther away from x equals 0, then there's going to be an error here. Okay, so that's the first part. This is called the object-oriented style for Matplotlib. Do you have any questions for me there? Is this the first time you see a Matplotlib code? Or you're an expert? Okay. Okay.
I have a question for you, Carlos.
Yep.
Where can I do these visualizations? So clearly you can do it in Colab, or a Jupyter notebook like you're demonstrating. But can I do the same thing in my own IDE on my local machine?
Yeah, any Jupyter notebook.
Not Jupyter notebook. Just running Python code in VS Code or something.
VS Code
Can I
understand the
visualize?
visualization. Because also VS Code understands your Jupyter notebook. So you can open Jupyter notebook using VS Code.
Oh, can you? Okay. Okay, so you need some kind of program around it to be able to make
Interface.
visuals.
Yeah.
Not just gonna run the Python code and it's not gonna
Yeah,
if your command line, like that's not gonna work. Right?
If you're using like a text edit,
Mm-hmm.
it only understands ASCII code.
Right.
So you won't be able of producing.
Okay.
You need the Python interpreter to understand the code and produce the plot, but you have to have a graphic interface. Once you have produced your graphic, then you can just download it and control right click, save image as, then you download it to your computer, or it will be in your Jupyter notebook stored with no problem. Okay, okay. So the second method is using pyplot. We're going to produce the same plot, but different method. So again, X is just a linear space between 0 and 5. I have 100 points. I'm going to set the figure size. So now I'm using PLT, and I didn't define a figure or anything. So PLT, that's the pyplot from Matplotlib. I'm going to use the function figure, and I'm going to set the figure size, 6 units on the horizontal, 10 units in the horizontal and 6 in the vertical. Also, I'm going to put a grid. So PLT grid true. And then I'm going to use the plot function from pyplot to plot x versus sine of x, x versus x, x versus x cubed, and x versus x minus x cubed over 6. And I'm just leaving the default colors for the line functions, and I'm using a dashed line to distinguish from the sum, since this is the Taylor series approximation. Then again, I'm having control on the limits on the x-axis from 0 to pi over 2, and on the y-axis from 0 to 1.5. And then I'm setting that the x-sticks, where I want the x-sticks on the x-axis, and also I'm going to be doing what I want them, the labels on the x-sticks axis. So I have 0, pi over 8, pi over 4, 3 pi over 8, and pi half. Then I put the labels on the x and y axis and the title, and then plot the legend to distinguish between one plot than the other ones. So I'll just execute, wait for the green check mark, and I have the same plot. So I can produce the same plot two ways, different ways in Matplotlib. And we are starting that we have some mathematical functions that we want to plot. Okay, what about if we want to do multiple plots? Okay, so again, we're going to create, again, we're going to have x-axis between 0 and 5, and y, we will have y, will be cosine of 2 pi times x times the exponential of minus x. And the second function, x, from 0 to 2. So the first one was from 0 to 5, the next one is from 0 to 2. And then y2 will be cosine of 2 pi times x, x2 in this case. So the method of axis, so this is the object-oriented. So we are going to have two subplots on a single row. So that's 2, 1. And the figure size. Let me go over. Okay. And then the subtitle, since I will have two plots, I want a single title for the two plots, the general title. And then I'm going to create the first plot. So I'm going to use grid for the first plot. And the first plot is just, I'm calling AX for the first plot, and I'm going to use AX2 for the second plot. So the first plot, I will plot a grid and plot x1 versus y1, following the definitions of in the previous rows. And I'm going to put, I'm going to use circles and dashes. And then I'm going to use label cosine of 2 pi x times the exponential. So this is LaTeX notation. And the label for the y-axis is going to be damped oscillation, since it's a cosine times an exponential with negative exponent. And the second plot is just the sine of x. And I'm going to use dot dash and label in x type, since they are functions of x. And label is undamped, and then PLT show will show the two plots. So I execute. Now I should have an error. What happened? I have an error. X1 is not defined. Yes. Okay. I didn't run this cell. Okay. Sorry. So now I have produced the plot. So I have two plots. And the first one is just a damped oscillator, which is a cosine function times an exponential negative. And the second one is just a cosine. So, and they have different domains. The first one goes from 0 to 5. The second one goes from 0 to 2. And I have a label for the x-axis, time, seconds, and the y-axis. One is the undamped oscillator, and the other one is the damped oscillator. So this is a way to having multiple plots using Matplotlib. Doesn't show up. I'm missing something. Which one? The labels in this case are going for the x-axis. So for the y-axis, so I have the damped and the undamped oscillator. And yes, so this one. Yes, I didn't show labels. Plot legend. We got that one probably. Okay, try again.
There's a question on in the chat.
Yes. It doesn't show up. What?
You see that?
Yeah. Yeah, it's not showing. Yeah, so probably this should go. ELT is the general one. If this can work here. Right. If not. No. Warning, legend. Yeah. So I have an error there. I need to look, see why it's not putting, but it's possible to do it. I'll just get it next week. Okay. And the second method is using pyplot. And then, yeah, when you start having multiple plots and every plot has its own instructions or functions, and then those plots or subplots are written in the same canvas, then you start colliding between access labels, and so you have to be aware of that. For example, if you want to have the same x-axis label when you have multiple plots, etc. Okay, so the second method is using pyplot, and we're going to do the same thing. And we have the two subplots again. So the first plot, they have coordinates, remember? So 2, 1, 1 will be the first plot, and 2, 1, 2 will be the second plot. So you have two plots, 2 rows, 1 column, and the first, I'm sorry, 1 column, 2 rows, and this is the first row, and this is the second row. That's how you should interpret. And then, of course, you can put more when you have. We will see an example when you have more than 2 plots. You can do 3D plots like surface plots. If you have a mathematical function, then you will use Matplotlib toolkits, Matplot 3D, and then we import those, and then we will have some aspect. So you need to, in 3Ds, you have to say, where are you looking the figure from? Like, what is your aspect and eye position, etc. So if you have done 3D plots using MATLAB or Matplotlib, you know what I mean, or Maple or Mathematica. So in this case, we're going to add subplot. So this would be one row, 2 columns, and the first plot, projection 3D, and this is the AX. So we're using object-oriented plot, and then X will be from -5 to 5 every 125, and y will be from -5 to 5 every point 125. We're going to plot a mesh grid for xy. R is going to be just the square root of x squared plus y squared, so it's a sphere, a circle, I'm sorry. And C is just going to be the sine of R. And then we're going to plot a surface using X, Y, and Z. And these are some parameters: R stride, C stride, and color map. I'm going to use a color map schoolworm, line width 0, anti-alias false. This is for reflections. And then we're going to control the Z, the limit, the domain in Z from -1 to 1. And we're going to put a color bar on the surface. We're going to shrink it and have some aspect ratio. So that's the first plot. The second plot will, again, will be a projection. And we're going to make a 3D wireframe like. And we're going to, instead of plotting a surface, we're going to plot a wireframe. And execute, and we will be producing the 3D plot, one surface plot and one grid plot or wireframe plot. And we have the color table map here. And that's a very simple 3D plot. Okay, any pending questions? So these are just basic applications of Matplotlib using mathematical functions. In what follows, we will be using a data set. So we are going to be using the penguins data set, which is a collection of 3 types of species living on 3 islands in the Antarctica. And the data set includes some measurements from each of the species, like the culmen length, culmen depth, flipper length, body mass, and then categorical variables for the species, the Shinstrap Adelie, Gentoo, and the island name, Dream, Torgensen, and Bisco, and also the gender. And these are the 3 types of penguins. And we're going to use, we're going to call all the different libraries, and we will be focusing on first on the Matplotlib, and then later we will start talking how to do it in Seaborn, but you have the code there, so no problem. Okay, so we import these libraries. So we have the visualization Matplotlib, Seaborn as CNS, SNS, Plotly Express as PX, and Plot9 as P9. And then we will be reading the penguins data set using pandas, read CSV. File name is somewhere on a GitHub. And we're going to print the first 5 lines or 5 rows of the data frame. So this is how the penguins data set looks. So these are the rows, 0, 1, 2, 3, 4. And these are the species, the column species, the column island, which are categorical variables. And then we have numerical variables. And at the end, the gender. And we have some missing values. So we use pandas dfinfo to check the general information of our data frame. So we have 344 entries. We have 7 columns. These are the names of the columns. We have some missing values because for one column we have 344, for another column we have 342, and for the gender we only have 334 values. And these are the types of data: objects for species, island, and sex, which are categorical variables, and numerical floating 64 bits for the dimensions. Okay, and then we there is one thing. When you look at the column for sex or gender, we have 168, I think, male, 165 female, and we have some additional, which is not a male or female, it's just a dot. So what I will do is just clean the data frame. So I'm going to make a copy. I'm going to drop all the missing values. I'll make a copy. And then I'm going to select only the rows where the sex is not equal to dot. And that will be df1. So I will just execute. Now, and I do the info function. So now we have 333 values in all the columns. So this is the df1 is just the clean data frame with no empty values in the rows and only the two selected genders, sex, male and female. Okay. Now we're going to be using, well, let me talk about how to create different figures and subplots. So what are the steps? So first, we're going to use the figure function from Matplotlib PLT, and we'll call it fig. And then AX1, AX2, and AX3 we are just going to add subplots. So we want to have like 3 plots. So we have 2 columns and 2 rows. So the first one, AX1, will be this one. AX2 will be that one, and the 2, 2, 3 will be this one. So we have the first figure, the second figure, and the third figure. And we have a matrix of 2 by 2. And then once we have the bounding boxes for the figures, then we will create the contents. And once I have 3 boxes, I can fill the boxes with different types of plots. So what we're going to do is, well, first define the figure size, 12 units in the horizontal, 8 in the vertical. And then we add different plots. So we have again AX1, AX2, and AX3, the 3 boxes. And then for AX1, we'll be plotting a histogram of the penguins data set or data frame. We're taking the body mass column. We're going to create a histogram with 20 pins. And we are creating the histogram in blue. And we are giving a transparency of alpha of 0.4. So that's AX1. So this is the first plot. AX2 is going to be a scatter plot of the Coulomb length versus the Coulomb depth. So X is the Coulomb length and Y is the Coulomb depth. Color orange and marker this inverted triangle. So that will create my second plot. And for the third plot, I will use a box plot of the flipper length. So this is the box plot of the flipper length using Matplotlib. I have a question in the chat. Oh, it's just an abbreviation of the previous figure. So I'm just continuing with the creation of the plots. So this is just what was referenced before. It's a fancy way of doing it. You will find it in some examples on the internet. Okay, so now we have the basic. So we know how to create the 3 boxes. Then we know how to populate the 3 boxes. Now we are going to add text labels and legends to the previous plots. So again, we continue with what we were doing. Now we need to work the details on the first plot. So I want X ticks on a 3,000, 4,000, 5,000, and 6,000. So I only want 4 X ticks. And the X ticks labels, I'm going to change, since the body mass is in grams, I'm going to change into kilograms. So instead of putting 3,000 grams, I'll put 3 kilograms, 4 kilograms, 5 kilograms. And then I'm going to rotate the labels 30 degrees, and I'm going to use small font size. And then for the title, I'm going to put penguin's mass distribution in kilograms. For the second plot, I'll put the X sticks on a 30, 40, 50, and 60. And also again, I'm adding 3.0, 4.0, 5.0, and rotate it 30 degrees and put the culmin length. Since these are millimeters, so I'm going to be using centimeters. So that's why 30 is going to be replaced. 30 millimeters is going to be replaced by 3 centimeters, and so on. So the same thing for the culmin length and the culmin depth, and then the title will be culmin depth versus length in centimeters. The third plot, I'm going to be using, since I'm plotting the flipper length in millimeters, I'm going to put in centimeters. So I want 5 X ticks, and these are Y ticks, and these are the Y labels for those ticks. And then something optional, yeah, some subtitles. So I just execute. So now we have some warnings, but now we have customized the different plots for every box, right? So we have flipper length now in centimeters. I have the penguin's mass distribution in kilograms and the counts, and the culmin depth in centimeters versus the, yeah. So I have the scatter plot, the culmin depth versus the culmin length in centimeters. Okay, so you saw now how can I go into the detail to populate and create some multiple plots, starting from plotting the bounding boxes, and then filling different types of plots for every box, and then filling the details, labels, legends for every box, so we can have something similar like this. Okay, so do you have any questions for me? Either way, you have now this Jupyter notebook on your Google Drive, and you can copy, paste, adapt to whatever you're trying to do. And what is next is doing the same thing and now combining different libraries, how you do it in Matplotlib, how you do it in Seaborn, how you do it in Plotly, how you do it in, I have some example for the other plots, Bokeh and Plotly and Plot9. So I will do that, or start from here next week. We will continue using the same Jupyter notebook, and then comparing how to do it in every, using different libraries. And you will see that sometimes it's easier to do it probably in Seaborn or Plotly, and then doing it with Matplotlib. But Matplotlib, you have complete control of every part of your plot. And if you use Seaborn, they will come with the specific default values. And if you don't like them, the good thing is that Seaborn was created on top of Matplotlib, so Seaborn understands additional Matplotlib commands to override the default values for Seaborn. So it's a convenience way of doing visualization, combining different libraries. So you can get, finally, you can get the visualization plot that you want for your publication or dissertation or paper. Okay, so that's what I have today. And if you have any questions,